There you go. All right, sorry, we had a little bit of technical difficulties, but welcome to the grade 6, 7, and 8 Math Kangaroo Live Solve. So first, I'll just introduce Dorothy to all of us. So she came from San Francisco, California, but now she's studying at the University of Oxford. And during high school, she was a four times Amy qualifier. She was a science Olympiad captain, and she was also a cross country captain and soccer referee. So all sorts of different activities. Other than that, she also attended the MMSS summer camp and the HCSSIM summer camp, and also really loves the number 17 and its multiples. Outside of all these academics, she loves to learn languages, play the violin, and sometimes the viola, sometimes the kalimba, and the piano. She likes to hike with friends. She likes to do crocheting, cartography, cooking, crosswords, cryptography, and all other C words. She also really likes telescopes. So everyone say hi to Dorothy.
Hi guys, and thank you for that introduction, William. I'll be introducing William now. William is a senior at Lexington High School. He's the 2022 Massachusetts Math Count State Champion and has achieved a perfect score on the AMC 8 in both 7th and 8th grade. He's also qualified for the Amy since 6th grade, wow, and he qualified for the USA JMO in 2022 and 2023. Outside of math, he's passionate about cybersecurity, Rubik's Cubes, card games, and playing with his dog. Everyone say hi to William.
All right. Thank you, Dorothy, for the introduction. And if in case you guys haven't figured it out yet, to put your messages, put your thoughts in the chat right here, you want to go to chat relay 678 in the Zoom meeting, and then, or wherever you're watching this from. And then after you message chat relay 678, your message will be able to pop up on the screen.
Yeah, so everyone try out messaging chat relay right now and see if you see your message show up right down here. Cool, looks like a lot of people are figuring that out.
And yeah, a lot of people are noticing. Maybe I should just start saying grade 6 to 8, right? That would be a little better for the rest of this
Yeah.
class, because otherwise it seems like this is distracting you guys a lot. So I think it would be better if we focus on the math a little more, don't you think, Dorothy?
Yeah, I think we might have to say middle school or grade 6 to
Oh,
8
middle schooler,
instead.
that's better.
Yeah.
Yeah, whoever made this live self did not
It's
consider
unfortunate for
their
sure.
intended audience very well. So, let's see. Professor Lowe will be here to introduce the live solve to us very soon. But before we get here, what do you think, Dorothy? What do you think we should? Are we missing anything?
No, I think we just wait for Professor Lowe. Do you guys want to tell us where you're coming from in the chat just while we wait?
Yeah. See, like
I'm
I'm
from
from the US
California, or
and
I'm in California right now.
Dorothy.
William, are you in
Oh, you are?
Massachusetts right now?
Okay. I mean, normally Dorothy's in the UK, right?
Yes. Oh, there's another person from California. Ooh, a couple others. That's cool.
Wait, so we have multiple people from Ohio as well. That's interesting. We have Maryland, North Carolina, New York, Pittsburgh. Lots of United. Oh, see how it says Massachusetts? I'm from Massachusetts, actually. It's so cold right now. I'm wearing a coat on top of my sweater. But outside of the US, I was wondering if anyone is from like another country, perhaps.
Yeah, I feel like the time right now isn't great for that because I know in the UK it'd be past midnight right now. But maybe in Asia somewhere could be joining in.
No,
Oh,
I think they're
Professor
all from
Lowe's
the
here.
US. All
Hi
right. Oh, Professor
guys,
Lowe's here.
Hello.
I made it over. Yes, yes, yes. Nice to see you guys. Oh wow, Dorothy, last time I saw you was over in England. That means you're probably in England right now too.
I'm back in California now.
What? Oh, yes, your semester is so short. Okay, that
Yes,
makes sense.
yes.
Okay, well, it's not really a semester, it's a term. Okay, well, first of all, it's a real pleasure to be here, and let me give a little bit of a welcome. I'm just setting up my technology to match. I think this should work now. Maybe? No, maybe not. Just a second. I'm just making sure that oh yes, my system works. Good, and my chat's on the screen. Wonderful. Okay, well, first of all, welcome to the channel. I'm glad that you already got to meet a little bit of Dorothy and William. They are our incredible instructors from Live, and we're very, very pleased to be running this collaboration again together with Math Kangaroo USA. Math Kangaroo USA, we like because of the creativity that's involved. The reason I was delayed actually was not because I was in Asia, but it was because I was in the other corner of the internet called the Math Kangaroo grades 3, 4, 5 room, which we're running at the exact same time. And I was just running from that to here. Although I am not at home, that is true. I happen to be, wait, let me go and make sure my thing is spawned. 1 second. Oh, it is. But I happen to actually be calling in from Oklahoma because I just finished my semester and now I'm running around different parts of the United States sharing ideas about math. Well, we're happy to collaborate with Math Kangaroo because they do work not only with USA but the entire world, and they spread love and interest in problem solving, and they're really big on creativity. And we're also very happy to collaborate with them because they often will bring a official representative of Math Kangaroo USA. And what I'll do here is I'm going to introduce the representative, and I'll introduce Aina. And after that, Dorothy and William will take over. I will actually drop off because I'll pop off into something else. But let me tell you a little bit about Aina. She's awesome. So she's the founder of Georgetown STEAM Academy, and she was the Math Kangaroo DC State Director. I guess that's DC as Washington DC. Is that right? So must be. So that's the DC region director. But she grew up in a family of math teachers. Uh, both of her grandfathers. Just a second. Let me get this straight. Yeah, she was growing up in a family of math teachers. Both of her grandfathers were mathematicians, and one of them even served as the Minister of Education. That's pretty impressive. Her dad
Yeah.
was yes, and her dad was a statistician, and she is from Kazakhstan. That
Yeah,
was my
correct.
guess because I've also been to Kazakhstan. The
Ah,
international
you've been to
Olympiad,
Kazakhstan.
yeah, the International Math Olympiad in the year 2010 was in Astana. So
Ah,
as soon as I saw
that
you, I said, "Ah, this
very,
person looks like she's from Kazakhstan."
very impressive.
Oh,
Yeah.
well, it was a great experience. And just telling you a little bit more about Aina, she was immersed in a household where math was an important subject, with dinner table discussions about math concepts, problem-solving strategies, and solving all kinds of math questions that require critical thinking or thinking outside the box.
Mm.
And well, she went to special school. Between 1992 and 1996, she was in physics mathematics school, and she had a concentration in aerophysics in Kazakhstan. But then she came to the US in 2007, came to Boston, Massachusetts to do her master's degree in sustainable development, and afterwards taught graduate school level developmental economics. Since 2018, she started to teach math, geometry, and algebra to students who are younger than college, K to 8, and she opened her own math enrichment center in DC. And she currently is in the DC Math Kangaroos DC State Director, proudly promoting the importance of math among young mathematicians like all of you. With that, I'll pass it over to Aina.
Yeah.
I will drop off.
Yeah. Thank you, Professor. Thank you,
Yes, nice
Professor
to see
Law.
you
Okay.
guys.
All right.
Bye.
Thank you. All right. Greetings from the nation's capital, DC. So, Washington, DC. So Math Kangaroo, we know that this is very exciting international math competition that, we conducted once a year in March, right? The third Thursday of March. So this upcoming year, it's going to be March 19th, 2026. The deadline for registration, you may know all, right? It's December 31st. And then this year, the questions will be very exciting because, the conference on selecting problems, questions for the upcoming year, it took place in Turkey, Istanbul, this year in October. I think it was between 15th and 19th October. And the questions are very, selected, I'm sure, professionally, as usual, full of creativity. And please welcome to Math Kangaroo and go to our website mathkangaroo.org, and you can see a lot of practice materials as booklets, books you can purchase, or there are some of them are free of charge. And also you can even register on some practice online classes. So that would be very, I think, helpful for many of you. So to get some higher scores, right? I'm sure you've been doing it for a long time, so you know everything about us. And for the new ones, new students, please follow us on Instagram because to keep yourself updated and tuned to our news. And yeah, what else we can say that over 6 million. So this is a very impressive. I was reading it, over 6 million students annually participate in every year in Math Kangaroo. So that proves that Math Kangaroo is really brings joy, and it's very popular among students, among educators. Also, for the educators, we can suggest you should bring Math Kangaroo. If you don't have it in your school, you can bring Math Kangaroo to your school by registering your school, your centers, or parents. You can open up your own centers. So in that way, you can spread this, math creative vibes. So thank you so much. Enjoy.
And with
Thank you.
that,
Mhm.
Dorothy, I think it's time for us to jump into the Math Kangaroo problems. What do you think?
Yeah, let's take a look at what we have for today. So here's the first problem. From the following numbers, 3, 5, 2, 6, 1, 4, and 7, Masha chose 3 numbers with a sum of 8. From the same list, Dasha chose 3 numbers with a sum of 7. How many of the numbers chosen by both girls are the same?
So each person chooses 3 numbers, but one of them asks to 8 and the other asks to 7. So I'm just gonna write out our numbers again, but in order. Because right now it's just a little shuffle, right? It's
Yeah.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right. So we need to choose 3 numbers that add to 7 here. Well, the minimum possible sum that we can get is 1 plus 2 plus 3 equals 6, which is off by 1, right? So, Dorothy, how do we go from 6 to, oh my God, how do we get from 1, 2,
You
3
walked
to
right into that.
3 numbers that
But
sum
I'm
to
thinking
7?
we can swap the 3 out for a 4, and then we get the second lowest sum, which is 7. So if we take 1, 2, and 4, we'll have 7. And we know there's only one way to make that 7 because we checked the smallest. That didn't work. And then we're checking the second smallest. There's still only one way to do that. So now we need the sum of 8. William, how should we find Masha's numbers?
Well, to get from 7 to 8, you just add 1 to one of the numbers, right? I'd say if we had 1, 2, 4 before, we can change this to 1, 2, 5. That'd add to 8. Now, an alternative thing that we could do is go from 1, 2, 4 to 1, 3, 4. And you could also go from 1, 2, 4 to 2. I say 2, 2, 4, but you actually can't do 2, 2, 4 since you can't use the number 2 multiple times. And what you'll notice here is that when 1, 2, 5 shares 2 numbers with 1, 2, 4, right? And 1, 3, 4 shares 2 numbers with 1, 2, 4. So no matter what numbers that Masha chooses, the answer is going to be 2 numbers. Is that right, Dorothy?
Yeah, so some people might think it's impossible to determine just because there are different ways to find Masha's number, but the key thing here is in both of those ways, it still shares 2 with Dasha's, so the answer is going to be C, 2.
And let's just see if our answer is right. All right, yeah, it is 2.
Nice.
Okay. So how about Our next question is going to be problem 23. So we're given three digits A, B, and C, and they're all different from each other. Now, the greatest possible number that uses A 3 times, B 2 times, and C once will never be written in which of the following forms? AAA, BBC, CAAA, B, and so on.
Yeah.
Now, the tricky part about this question is that we don't know if A is greater than, less than, or equal to B. We don't know if B is greater than, less than, or equal to C, and so on. So instead of looking at these relations, what do we look at, Dorothy?
Well, I'm thinking we can look at the answer choices because there's got to be one that looks different from the others that has to stand out in some way, right? Because it's saying that four of these are potentially valid forms based on certain A's, B's, and C's. So, well, it looks like a lot of people in the chat are seeing the right one. A lot of people are saying D. William, can you tell me what's weird about answer choice D here?
So most of the answer choices are these letters appearing in continuous blocks, right? We have a block of three A's, a block of two B's, and then one C. Same goes for B. One C, a block of three A's, and a block of two B's. Now, the weird thing about D is that the B's get disconnected from each other. There's a C in between them. And that will give you a good guess that D is going to be the right answer. But how can we be for sure that D is the correct answer? So if B is less than C, then that means that this should be AAA CBB instead, right? This would already be greater than our current number. So that means B is less than C does not work. If B is greater than C, then we would do AAA BBC instead of BCB. So that means that neither case would cause this number to be the greatest possible greatest possible number. And that's how we get our answer of D.
Yeah,
Is
and
there
it's important to
another
note
way
here that
to?
this is because there are three different digits. If C was equal to B, then it would be okay. But the question specifically says they all have to be different. All right, next question. Nick wants to arrange the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10 into several groups so that the sum of the numbers in each group is the same. What is the largest number of groups he can make?
All right. What's the largest number of groups you can make? Okay, so some of the numbers in each group is the same. So let's see here. When I see this question, I'd first take the sum of all the numbers, right? Since the number of groups times the sum of the numbers in each group will equal this total. Is that right, Dorothy?
Yeah, so what William's saying is we need to know that the number of groups divides the total sum for them each to have the same sum. So it might be helpful to first sum them all up and then find what numbers divide that total sum. So let's find that sum.
2 plus 3 plus 4 plus all the way plus 9 plus 10. So
Yeah.
there are two ways to do this. One, you could just add all of these together and you'll get an answer of 54. Now, a more advanced method would be if you know triangular numbers, the answer to this problem in general, the sum of the first k integers is equal to this. K times k plus 1 over 2. And Gauss has a really nice proof to it that involves pairing. Now, if you plug k equals 10 in here, you'll get 55. And you want to subtract 1 at the end, which will give you 54.
Yeah. And when we're talking about pairing, we mean you pair like the 2 and the 10, the 3 and the 9. You get a bunch of pairs that sum up to 12. And you'll find that in this case, we're going to have 4.5 of those pairs, which is how you get 54, is 12 times 4.5.
All right, and from here, we get that the number of groups has to divide 54. So our options are 1, 2, 3, 4 does not divide 54. So 6, and then we have 9, 18, 27, and 54.
Yeah.
So let's go look at our options. 54, 27, 18, 9, and so on. These large number of groups, these aren't really going to work because that would make the sum of the numbers in each group pretty small. And remember, we have a 10 that needs to go in one of these groups. So Dorothy, what numbers can we eliminate just from this fact?
Well, I think that means we can eliminate every number 6 and larger because 54 or 10 goes into 54 5.4 times. So if you're going to have groups of 10, you can have at most 5 of them. And I know we're not having groups of 10, but basically for 6, if we had 6 groups, each sum is 9. 10 isn't going to fit into that. And if we have any more groups, the sum gets even smaller. So the only choices we really have are 1, 2, and 3, right?
Mm-hmm. Yeah, so we want to find the largest number of groups we can have. So let's just start with the largest option that we have left, which is 3. Then each group is going to have 54 divided by 3 equals 18. Each group is going to have a sum of 18. And from here, we can try to construct our groups. I'm going to, use a new slide. First, let's deal with the 10, right? Since that's the largest and most annoying number that we have. We can pair this with the number 8 to get one group of 18. Next, let's use the number 9. And then we can pair this with 7 and 2 to get another group of 18. And Dorothy, how do we finish from here?
Well, let's look at the numbers we have left. We have 3, 4, 5, and 6, and those sum to 18. So we're done. We have 3 groups, each with a sum of 18.
Right, it seems like some people are also thinking that it could be B. Let's go back to the original question. All right, yeah. So it's not C because remember that the number of groups has to divide 54 since each group has the same sum. The sum of the numbers in each group is the same.
Yeah.
So that eliminates C, and that gives us the answer of B.
Because if we had 4 groups, they would each need to have a sum of 13 and a half. And that does not work here because we just have integers.
Okay, so now we're moving on to grade 7 and 8 questions. So during 2 sessions of soccer training, Paul shoots 17 times. All right, that's Dorothy's favorite number, right? Total of 17 times at the target. Now he hits 60% of the shots that he shoots in the first session, and he hits 75% of them in the second session. And this is enough information to determine how many times he hits the target in the second session. Very interesting. So we actually don't know how many times he shoots in the first session and how many times he shoots in the second session. We just know how many he shot in total. But there's something very interesting about the numbers 60 and 75. Like, these numbers are not chosen for no reason. And why is that, Dorothy?
Well, it's because they can be written as fractions that are pretty small. They have pretty small denominators. So we know that 60%, you could say that's 60 out of 100. But if we reduce this, we get 3/5. And similarly, if we reduce 75%, we'll get 3/4. So how does knowing these fractions help us, William?
So let's just say, like, very hypothetically, that Paul's first session only has 1 shot. Then how many shots did he make? He only made 3/5 of a shot. That doesn't make any sense, right? Like, the number of shots that you make should be an integer. So 1 shot cannot possibly be the number of shots he made in the first session. And in fact, the number of shots he makes has to be a multiple of 5. And that's because the denominator here is 5. So the number of shots that he took in the first session is going to be 5, 10, or 15. Now, how many shots did he take in the second session, given the number of shots he took in the first session, Dorothy?
Well, let's see. If he takes like X shots in the first session, then he took 17 minus X in the second session. And we also can write out the possibilities for the shots he took in the second session, just like we did before. So we have 5, 10, or 15 for the first one, And the second one needs to be multiples of 4. So we could do 4, 8, 12, or 16.
Hmm. And from now we are using the fact that in total he shot 17 times. So which two numbers here are going to add to 17? Certainly not 5, 4, not 5, 8, but 5, 12. 5 plus 12 is equal to 17. So looks like we found our answer here. He shot 5 balls in the first session, and he shot 12 balls in the second session. But the question asks how many times did he hit the target? Like how many successes did he have? So we have to multiply 10, wait, not 10, 12 by 3/4 to get an answer of 9.
Yeah. All
And it
right.
seems like a lot of people are getting that answer in the chat. So great job, everyone.
Perfect.
And
All
Dorothy,
right.
do you want to take this
Anurag
next
leaves for
question?
school. Yeah, it's this one, I think, right? Yeah. Okay. Anurag leaves for school at 8 a.m. His school is 1 kilometer away. When he walks, his speed is 4 kilometers per hour. When he bikes, his speed is 15 kilometers per hour. He is 5 minutes early when he walks. How many minutes early is he when he bikes? All right. So it tells us that he's 5 minutes early when he walks. And we also know exactly his speed when he walks and how far he's going. So I think a first step might be to find out what time he arrives when he walks. So
Hmm.
he's walking at 4 kilometers per hour, right?
Yep.
And his school is 1 kilometer away. So, William, how long does it take him to walk?
Now, a classic formula is going to be distance equals rate times time, right? D equals RT. But right now we are given distance and rate, and now we want to find time from this. So what do? We divide both sides by r to get time equals distance over radius. I mean, not radius, rate. And our rate is 4 km over h. So our time is going to be a fourth of an hour, right? And this is equal to 15 minutes. And since he arrives 5 minutes early when he walks, and he arrives at 8:15, that means that school starts at 8:20. School starts at 8:20 a.m. All right. So Dorothy, do you want to pick up the part where he bikes to school instead of walking to school?
Yeah, so now we do the exact same thing. His speed is 15 kilometers per hour. His school is 1 kilometer away. So we can do distance divided by rate. That is 1 divided by 15 to get 1/15th of an hour, which is also equal to 4 minutes. So that means he arrives at school when he bikes at 8:04 a.m. and he wants to be there by 8:20, so he's going to be 16 minutes early.
All right. See that a lot of people are getting that in the chat. Let's see if that's right.
Perfect, yeah.
All right, great job, everyone. It is going to be 16 minutes early. Okay, so this seems like this is the first geo question of the day, right?
Yeah, I think so.
Okay, it looks a little tough actually. So Ria draws 4 squares side by side, and in case it's not clear on my screen, I'll highlight these 4 squares. So one of them is here, another is here, another is here, and finally there's this teeny tiny one right here. And now we want to find the area of this quadrilateral. This, and this. Ooh, this is actually pretty tough. So how do we start this?
All right,
Well, it
well,
seems like, oh
sorry.
yeah,
It
go
looks
on.
like some weird shapes, right? So let's just cut it into shapes that we know. We can find some triangles here. And so if we can find the area of these more knowable shapes, then you'll be able to find the area of the whole thing. And you'll notice there's a ton of different ways to cut this into triangles. It doesn't really matter how you do it, but you just want to break it into shapes that are easy to find the area of.
Yeah, I really like Dorothy's method because now it's a lot simpler than what I had before. We have some four really, really simple shapes. And we just have to find the side lengths for each of these shapes. Is that right?
Yeah. And a lot of them are already given to us, I think. So, what do we do about this topmost triangle?
So the base looks like it has a length of 3 plus 4 plus 2 equals 9. And what about this altitude? This one is going to be a little trickier, but what you can notice is that this square that we have, it has a side length of 7. And then the one right next to it has a side length of 2. So this length right here is going to be 7 minus 2 equals 5. So great, we found the length of one of the triangles, so we can calculate the area of this. But before we do that, I think I'd rather find the side lengths of the other components as well before you do the area calculations. How's that
Yeah,
sound?
that sounds good. I'll just write it over here so we know to do it later. And then, well, there's this rectangle. This seems pretty easy to find the side length of. We know this is 3, this square here is 3, and we said that this part is 2. So this whole rectangle is going to be 5 by 3.
All right. So we have two more things to deal with, and I think I'm going to go ahead and take the easier one. This triangle, the small triangle here. So one of the sides we already have is 3, and the other one is going to be, oh, actually, this is, it looks like it would be 3, right? It looks like the same length as this. But how do we prove this? My diagram is getting
This
kind of
part
big on
is
the way.
6.
Ah, all right. Thank you, Dorothy. So because this square has a side length of 6, and this one here, this little edge I just highlighted here, has a side length of 3, that means that this is going to have a side length of 3. And Dorothy, you want to take the last one?
Yeah. So then the last one, I think we pretty much have all the lengths already. But if we have 2 here and 3 here, this whole thing is 8. And then the base of this, 4 plus 2 is 6. Taking this 4 and this 2. So that one's going to be 8 times 6 over 2.
All right, and let's just see. So all the calculations are on Dorothy's screen. So let's just do them real quick. 5 times 9 divided by 2 is going to be 45 over 2. 5 times 3 is 15. 3 by 3 over 2 is going to be 9 over 2. And 8 times 6 over 2 is going to equal 24. So now it's just a matter of some arithmetic. 45 over 2, 15, 9 over 2, and 24. So to get rid of these nasty denominators, we add these two together to get 54 over 2 equals 27. Now it's 27 plus 15 plus 24. This equals 66. Is that right?
Yes, I believe so. Alright, so answer choice C, which a bunch of you guys are saying in the chat. So glad we're on the same page with that.
All right, yeah, it seems like everyone beat us to it.
Yeah.
Awesome work, everyone. Do you want to take this problem, Dorothy?
Yeah, sure. So here the letters P, Q, R, S, and T represent 5 consecutive positive integers, though not necessarily in that order. The sum of P and Q is 69, and the sum of S and T is 72. What is the value of R? So here, I mean, it never hurts to just start trying things, right? We want 5 integers. They're all going to be around 36. And the way I'm getting 36 is the sum of S and T is 72. And 76 divided by 2, or 72 divided by 2 is 36. So what if we say S is 35 and T is 37? We'll see where we can go from there. Then we're going to need a P and a Q, such that P plus Q is 69. And we also want them to fit into these slots. So we could have a 36 to fill in this gap. And then if Q is 36, then that means P would be 33. And so now we need an R, and it looks like we actually just have one gap here. So if we put 34 in there, we're going to get 5 consecutive integers here. So R is 34. Here I got kind of lucky in that my first guess actually just turned out to work. You might not always get that lucky, but it's always good just start with one of these numbers divided by 2 and sort of play around with this.
Man, although Dorothy calls it a lucky guess, I wouldn't say it's that lucky because intuitively, since these integers are consecutive, S and T should be pretty close to each other. And the closest we can get are going to be 35 and 37, right?
Yeah, and you'll notice we could have also tried to move them even further apart. We could do 34 and 38, but then that seems like a little bit too far apart. We're not going to be able to find two that add up to 69 because both
Yep.
are too big.
And yes, in the end, we are going to. Oh shit, I went to. The answer says 66, but I think that's for the previous problem. But yeah, it's going to be 34.
Yes. I mean, we found an answer that works, and there's no way it's 66, so I think that's good enough.
And even though we don't have an answer key, it says that everyone in the chat is going to be saying answer choice C. So great job, everyone. Next question. Now we're going to go on to 3D geometry. Now, what is the height of a cuboid? Wait, when the height of a cuboid, that's how I pronounce it, right? Cuboid, is reduced by 3 centimeters, the surface area is reduced by 60 centimeters squared. And given that the resulting shape is a cube, what is the volume of the original cuboid? I don't think I've ever used the term cuboid before. I just say rectangular prism, but all right,
Yeah,
let's
to
just
be
stick with
honest,
it.
I don't know what a cuboid is.
It's just a rectangular prism.
Okay.
So let's say that this part, the cube underneath, has side length s. Its surface area is going to be 6 times s squared, right? Since each face has an area of s squared, and we have 6 of these faces. Now, when we remember, once we cut off this top part, these 5 surfaces. Oh, wait, let me try to explain this. Okay, here's a better way to do this problem. So the new surface area is going to be 6x squared, right? But Dorothy, how do you calculate the surface area of the original cuboid?
Well, we're going to want to add up all of the faces, right? And you'll notice 4 of them are the same. These 4 are all s plus 3 by s, and then we have 2 that are just s squared. So we got to this from 4s, s plus 3, plus 2 of the s squared ones. All right, so what do we do with this?
Okay, so if you expand everything in Dorothy's expression, you will get 6s squared plus 12s. Now, we're given that this surface area is 60 more than the new one, which means that this minus this is going to equal 60. Now, what does that mean? This means that 12s is going to equal 60. And then divide both sides by 12 to get s equals 5. And 5 is not one of our answer choices. How come? And that's because that's not what the question is asking for. The question is asking for what is the volume of this original cuboid? And Dorothy, do you want to finish for us?
Yeah, so the original cuboid was then 5 by 5 by 8. So we're going to do 25 times 8, which is 200. So answer choice D.
Very nice. Great job, great work, everyone. A lot of people are getting D. So let's move on to the next question, problem 27. Now we're going back to 2D Geo. So do you want to take this, Dorothy?
Yeah, okay. So here we have a quadrilateral with the points N and K marked on sides BC and AD, so that BN equals 2NC and AK equals 2KD. And we know the area of certain triangles here. We want to find the area of the whole thing. So let's see. I'm going to write in the areas that they gave us. The area of this triangle is 2, and the area of ABN is 6. So it looks like we really aren't missing that much to find the area of the whole quadrilateral. We just have this quadrilateral ANCK left. But it's kind of hard to find the area of just a random quadrilateral. So an easy way to do this might be to split it into 2 triangles. I would say it's always easier to split it, or to find the area of a triangle than a quadrilateral. So William, what do you notice about these 2 triangles now?
So these 2 triangles actually have a very special property. So let's look at triangle ACN. And that special property is that it shares the same altitude from A to BC as triangle ABN. And what that means is that we know that the area of a triangle is 1/2 times its base times its height. And triangle ACN has the same height, but half the base of BN, which means that its area is going to be half that of ABN, giving us an area of 3. And we could do the exact same thing for triangle ACN, except this time the 2 bases are the same length, meaning triangle ACK is going to have an area of 2. And finally, we can add all of these together to get an area of 13. Yeah,
Alright.
is there anything else? I think that's the only way to do this problem. Because otherwise, yeah, this question doesn't look very nice at first glance.
Yeah, and I think that's the simplest way, for sure.
Any other way is probably going to be extremely difficult, unfortunately.
Yeah. Ooh, okay, this is quite a mouthful. You want to take this one?
Oh, are you serious? Okay. I missed back when math problems did like person A, B, C, D, E instead of these names.
Yeah.
Okay, so some birds, including, oh my god, these are okay. We're given 4 special birds: ha, long, na, and trang. I definitely pronounced that wrong. But they're all 4 parallel wires. Do you want to draw a diagram for us, Dorothy?
Yes.
And there are 10 birds above ha. So these aren't the only birds. There are a bunch of other birds that are less special than these birds. 10 birds above ha. There are 25 birds above long, 5 birds below na, and 2 birds below trang. And the number of birds perched above trang is a multiple of the number of birds below her. So how many birds are there in total on this 4? Oh god, this is difficult.
Okay, wait, I'm just writing our information in a slightly less paragraph form. Okay. And then there are 5 below. No. Oh,
I'll keep the problem on my screen so
okay.
we can look between Dorothy's diagram and my problem.
Okay, yes. Is everyone able to verify whether or not this information is what was stated?
There are 2 birds below number of chances, number. Oh god, and there are 4 wires in total. That's going to be important.
Yes. I'll draw those back.
So this is going to be really difficult, but let's just get some like basic information first. So first of all, I can tell that bird H is going to be above bird L because bird H has less birds that are higher than bird L than that are higher than bird L does. And second of all, we know that bird H and bird L are not on the top wire. Because if they were on the top wire, there are 0 birds that are higher than them. So that means that bird H is going to be on this wire, or it's going to be on this wire. Does that sound right?
Yeah. Maybe we
And we
can just
could do
start by
that.
putting bird L pretty low down, like here, given there are so many above.
Hmm.
25 above.
And we're also given, we could do the same thing for birds N and T. We know that N has to be above T since T has less birds that are below it than N does. And from my intuition, I would say I'm gonna guess that T is here because 2 is a pretty low number.
Yeah. So that
Hmm.
means that this wire has two birds, one of which is L.
Yep.
And then these have to have 25 total.
Mhm.
So
Specifically, this
that's,
wire has 3 because N has five birds below it. I'm guessing that N is going to be here,
mhm.
and yes, these are going to add to. Okay, these 3 wires are going to add to 25. So where's H going to be? Um,
Well, H needs 10 above it. So if we put H here, then this wire has 10.
mhm.
This wire can have 12. And
Yeah,
so now
and
we
let's
just need
just
to check.
verify that
Yeah.
all of our conditions are satisfied. So there are 5 birds below N, that is correct. 2 birds below T, and an even number of birds above T. So 12 plus 10 equals 22. So that is going to be correct. There are
Cool.
10 birds above H, yes. And finally, are there 25 birds above L? 10 plus 12 plus 3 is going to be 25. So indeed, there are going to be 25 birds above L. So how many birds in total are there? It is going to be 10 plus 12 plus 3 plus 2 equals 27. So unfortunately, this problem is going to require a little bit of guesswork, but using some nice intuition, like noticing that T is probably going to be on this wire since 2 is not that big of a number, we can get a pretty nice guess that actually works on our first try.
Nice.
Is there anything, Dorothy, is there like another solution you could think about for this?
I feel like you could come up with a system of equations and hope there was enough information, but honestly, I think intuition might be the move here. Just if you're in a competition scenario, you need to get it fast, and if you want to really convince yourself, you can always go the systems route and see
Yeah, I
how.
think because like we have pretty much no information about the special birds, we have to do a little bit of intuition.
Yeah.
All right. Oh my God. All right, you're taking this question. I'm sorry.
Okay. So we have a net of an octahedron, and we're going to color the octahedron with three colors: black, dark gray, and light gray. I may decide to say this is instead green, just for visibility. And we can do yellow for dark gray and orange for light gray. All right. Okay. And so we're coloring this such that the parts that come out of the same vertex or out of opposite vertices are of the same color. And we need to find the color that this part is going to be. So it looks to me like we just start coloring. What do you think, William?
Yep. Sounds like a plan to me.
Okay. So we can start with these have to be orange because they're all coming out of the same vertex.
Yep. And I can also see that this is going to be green. And now
Yes.
we're already a little bit stuck. We can't get too far with the condition that uh parts that come out of the same vertex are going to be the same color.
I
But
think we
we
get these yellows
are
as well from that, right?
is that is it? Wait, hold on. You-
Wait, do I not know how to fold an hold on.
I don't know. This net is very interesting. Hmm. Do I not know how to do this either? Wait.
Oh, no, no, I lied.
No,
Those
it's
are
not. I don't
not
think it's
touching.
yellow because what's going on here is that this is also going to be a triangle after we fold everything.
Yeah,
So this is
and
the
it's
yellow
gonna take
vertex.
these.
Yeah.
All
But I
right.
was thinking that this should actually be yellow. And the reason behind that is that parts that come out of the opposite vertex are also going to be the same color. And if we look at the original octahedron, you'll see that this is going to be a yellow vertex and this is also going to be yellow. Is that right?
Yeah. So here we're saying this goes here, this goes here. So that makes them opposite. And I think we can do the same thing with these greens. The opposite vertex will be this one
These
here.
greens are little. Wait. All right. I actually don't think that's green. Hold on. I'm going to map this net onto this octahedron. All right.
Yeah.
So we already have a yellow here and a yellow here. And we have this orange vertex. Let's say it goes here, right? And then right to the left of it, that's going to be a green vertex. So, well, actually, no, I think Dorothy got it. Yeah, this is going to be a green vertex because of the opposite color condition. This is tricky. Oh my God.
Yeah. So this vertex basically is going to be opposite this vertex when you fold
Hmm.
it up.
Yep.
And then that makes this green. These two vertices are actually, this is the same vertex. So that makes these yellow.
I'm also starting to notice a pattern that each triangle is going to have one yellow, one green, and one orange. And that makes sense because after we finish the coloring on this 3D object, you'll see that there's two of each color. They're distributed equally. So that will make the rest of this process a little bit easier. This is going to be orange. This one is going to be yellow since it shares the same vertex as these two. And then you can just keep going. These are all going to be orange. Remember, each triangle has one of each color. So this is going to be green. This shares a vertex, so it's going to be green here. This is going to be yellow. This is going to be yellow. And finally, this is going to be green. Does that look good to you, Dorothy?
Yeah, I think we did that right. So that would mean we used green to stand in for black. And we didn't make any guesses or arbitrary choices here. So that means if we did this correctly, black is the only color that it can be.
All right, this is a tricky question, so let's just see. All right, let's get a drum right here. Oh my God, that's not the answer. Only light
Uh-oh.
gray? Wait. All right,
Light
hold
gray.
on a second. Which color could? Let's see what the chat has to say about this.
Yeah, do you guys see our issue?
Hmm? Wait. So, all right, this is very interesting. We're not reading this wrong, right? In such a way that parts that come out of the same vertex or out of the opposite vertex are the same color. And which color could the part marked with the dot be colored? Is this yellow? This is yellow. Um, Do you see the issue yet?
Yeah. Because if you color in the last two, it seems like it does work. Wait. Like there's nice symmetry going on.
Wait, I don't understand.
Anyone in the chat see a mistake we maybe
Wait,
made here?
it'd be so much easier. Light gray is the only color that is not a ray slash symmetry line, says Yash. Light gray is the only one that's not a ray slash symmetry line.
Let's see.
Oh wow. Um,
Light gray.
Fortunately. So it's saying that this should be orange according to our color scheme. Is it
Yes.
possible that the colors got inverted and like black actually represents light gray on the original test?
Um, it's possible.
Oh,
Not
I
probable
might have to be
though.
like trying to, because
Albert's
I'm still
suggesting we just say
convinced. I'm
E
still convinced
because
that it should be green.
yeah, wait.
Hmm. There should only be one color. Yeah. Man, why couldn't they just they could have just used like letters, not not these colors, but all right.
I think wait. Hold on.
No, I'm pretty sure it's going to be green.
I think it
I
can't
don't think.
possibly be light gray because say this is light gray, this is light
Yeah.
gray. Then that means
Uh-huh.
this is light gray, and then you're gonna
Yep.
fold it, which means this is light gray. And these are also light
Yeah,
gray.
that doesn't make sense.
And
I
suddenly
think
we're
our
getting a
answer is
one
going to be
color
correct.
triangle. And we can't have that, given
Yeah.
we have this one with three colors.
Interesting. Oh, that's a little disappointing, but let's just move on to the last question. We only have 2 minutes left, but let's just see if we could get this in time.
Yeah, let's speed run it.
All right. So we have 5 boxes, and each box contains one and only one color, and no two boxes have the same color. Now, Lily wants to know which one has the golden one, and all of these statements are going to be true. Now, the ones that suggest so which of the following boxes does she have to open to make to for her to know which one has the golden one? Well, these two point to golden a lot, right? Golden or red, black or golden. So if we know that this box is not red, then we know it's golden. If we know that this box is not black, then we know it's golden.
Well, but there's
So
also the not black box, so this could have golden in it. So I'm thinking if we open this one, then everything will like fall apart, basically, and we'll be able to
yeah,
see
that's my guess.
what goes where. Just because, yeah, the not black is suspicious. It doesn't give us enough information.
Hmm. So either this box is going to have golden in it, or this box is going to have, if it has red in it, then the answer is going to be A. If this box has pink in it, then this one's going to be black. So this one's going to be golden. And if this one has white in it, then this is going to be pink, this is going to be black, and this is going to be golden. So yeah, that's a very interesting question. And at the end, we're going to get answer choice of D. So
Yeah.
that is going to be it for today's Math Kangaroo live solve. Thank you everyone for attending. Hope you guys had a great time learning about these with us. And Dorothy, what do you have any other comments?
I don't think so. Just thank you for all being so active in the chat. And yeah, have a great day, guys.
All right, thank you everyone. Bye bye.
Bye.
Bye everyone.